from anomaly detection to threat mitigation. So I would like to thank our respected dignitaries, resource persons, and all the participants for joining us today. So I hope it will be a clear, valuable, and enriching experience for all. So without further delay, let's begin the session with today session introduction for our speaker. So Dr. Pradeepthi is currently working as associate professor in C.R. Rao Advanced Institute of Mathematics, Statistics, and Computer Science, University of Hyderabad campus. So her research interests are in the areas of cybersecurity, machine learning, and computer networks. She obtained PhD under UGC PSR funding from College of Engineering, Hyundai, Anna University, Chennai. So she previously worked at Infosys Technologies. She is leading the cybersecurity and AI group at CR Rao Institute, and as project investigator, she successfully executed Government of India funded projects. She has developed guest lecturers for DSCI, MOSPI, SBI, DHL, and other government organizations. She teaches security and machine learning courses at the postgraduate level programs. Thank you, ma'am. We welcome you for today's session. Thank you so much. Good morning, everyone. So today I've been mandated to talk about certain topics in cyber and AI. So I have a little bit put together some slides in that domain. So I'll maybe there'll be repetition for a couple of slides. So just bear with me, like maybe because it looks like this is the last day and you've already many speakers have spoken. So sir, I just got feedback from the organizers, but because mostly you've had industry talks and a bit of hands-on and tools-based experience. So I thought I'll talk to you about case studies. Certain open source case studies and certain are our own in our lab, what work we have done. So that case studies I have put together so that we can discuss about that. And I thought that will be good for closing, like as the last session. So today I will re-emphasize now, like why AI and cyber security are actually being talked together, like how they are going to go hand in hand. And I'll also talk about some real-time case studies, like I said, and also I'll be talking about some emerging work which is happening in this domain, especially in the R&D perspective. So, kind of. So firstly, I just want to talk about our institute, like where I'm working right now. So we are an R&D institute located in university campus. So we basically undertake R&D for computer science and maths and stats related projects. So we basically work on cryptography, cryptanalysis, network security, wireless security, IoT, and other domains in cyber. Mostly, if you see, we are mostly working in cyberspace. And we also are working in the AI field where we are augmenting cybersecurity with some AI techniques. And we do projects, funded projects for central government agencies or various defense agencies. And we also offer master degree and BTech degree programs, but teaching like academics is something recently we have ventured into. We are more of a R&D organization. So we also do training, specialized customized trainings for government based on their requirement. So this is what we do basically. So at the institute, we have expertise in network security, where we do protocol analysis, deep packet inspection kind of works, and we do Android security, where we do app level security analysis and OS level security analysis as well. And wireless security, my colleagues work. We have a lab, fully established lab, where we work on Bluetooth and 4G, 5G analysis, and some of the we have some base station kind of setups with BLEs and other things. So we do some work there as well. My other colleagues work in cryptography where they do design and analysis of symmetric ciphers, like the block or stream ciphers, and cryptanalysis also. So I am mostly into the network and Android security space. And we also have some blockchain based work that is happening at the institute. We have an indigenous blockchain setup at the institute where we are working. It's a zero knowledge proof and it's a fully indigenous blockchain which has been developed. And some of my colleagues who are into maths, actually, they are working in post quantum cryptography and quantum cryptography areas. So this is about our institute, the work that we do. So this now I'm scoping down to my specialization where we do a lot of work in cyberspace, where we do malware analysis and predictive analysis in the various cyber attacks. Basically, we do the attack anomaly detection and other stuff, where we apply AI and ML. So that's about the institute and our domain per se. So now coming to today's thing, I'll, like I said, I'll initially discuss some challenges and then I'll talk about some case studies. So by now you are aware of what are the cybersecurity subfields, right? I mean, network security is one popular subfield, and then you have application security, information security, which is more to do with security of systems which are in which are stationary or static in nature, and operational security, and so these are the topics that mostly will come to our mind when we think about cybersecurity. So these are these challenges in cyber security space as of now, as on today. Ransomware attacks, social engineering attacks, state-sponsored attacks, and data breaches, insider threats, and AI-driven attacks, and 5G and IoT threats. So these are the emerging threats. There are other threats also like malware and other things which have been there for almost a decade, but these are the current evolving the landscape in cybersecurity. I would consider these as the current threats, which are new. And so to deal with these current threats, people are coming up with behavior analytics, advanced threat prediction methods, and we are using artificial intelligence and AI along with cloud and other technologies for mitigating these kind of attacks. So these are all the so for doing so, we are talking about AI and ML techniques. So this I will not explain much because all of you are faculty, so you are all very well aware of AI and what are the subfields in AI and how they are going to help us. So just briefly, so we have to whatever problem we are taking up, we are either going to convert it into a regression problem or a classification problem or a clustering and optimization problem. And if we are able to do so, then we can apply to any problem the AI solution, right? So we can nowadays we are using it for forecasting. We are using it to build recommendation systems in computer vision also. So any problem in any domain, if I'm able to convert it into either an optimization, prediction, classification, or a clustering problem, then I can use AI or ML to solve that problem, right? So how am I going to convert any problem in cyber security into an AI or ML problem? First of all, today's AI actually is going to help me. It's going to aid me a lot in the solving cybersecurity problems. How is it able to do so? Is there is a lot of automation in the which AI helps me to do. So if a human being is made to sit and screen every incoming packet at a firewall level or at router level, it is a very tedious and not a very it cannot be done in a limited time space. There is fatigue and other issues. But AI helps me do that automation and still get a competitive edge when I'm doing the automation. It is going to minimize the human error involved. So there is a lot of demand for cybersecurity professionals who also know artificial intelligence so that they can use it to help them do their work better. So the role of AI and ML in the cybersecurity, we can, as of now, think of using it for, or people are already using it extensively in detection and prevention of threats, like intrusion detection systems based on AI or ML methods, malware detection and analysis based using AI or ML, anomaly detection using machine learning. In predictive analytics also, based on historical data, can I predict the or forecast some attacks that we can think of using AI ML methods, and we can also do risk assessment using AI ML, right? So you have also, I think so, as part of the program, learned about incident response, how you can do it using artificial intelligence also. So these are the problems which I can attempt to solve using artificial intelligence and machine learning. Uh, and you can develop systems where in threat intelligence you can gather and analyze threat data and do threat hunting. We can do endpoint security analysis where I can do behavioral analysis and zero-day threat detection also. In network security, we use AI a lot for traffic analysis because as an anomaly detection problem, this is a good problem to analyze the traffic, and for behavior monitoring also. And user authentication using behavioral biometrics is also a good problem which can be solved using AI and ML. So how is AI able to seamlessly integrate and help us solve cyber problems is because inherently AI has this concept of continual learning. So the algorithm is going to continually learn from the data, and it can handle data based in even if there's something called class imbalance or other such issues. There are methods in AI to help you overcome those problems, and it eliminates tedious tasks easily. So these are the reasons why AI is able to seamlessly integrate and help me solve some cyber problems. So there are so like we are seeing that there are many positives, but there are some issues or challenges also when I'm trying to apply AI and to cyberspace. Firstly, the problem is of false positives and negatives both. So what is a false positive as far as a cyber attack is concerned? So there are two classes, attack or non-attack. So what is a false positive in that space is if an attack is put under a non-attack category, it's a very dangerous thing, or it's a very if the same thing happened in biological space or disease detection, it's almost life threatening. Here it might in cyber it might not be as critical, but it still is loss of reputation and loss of some revenue if we do categorize things oppositely, like attack as non-attack or non-attacks as attacks. Both are going to be revenue diminishing task. So that is a problem. So when we are designing any ML algorithm to solve cyber problems, along with accuracy, we want it to have lesser false positive rate. So that is another thing. Whenever we design ML algorithms, we are always looking at accuracy. And when we get more than 90% accuracy, we feel that it's good enough. But when you're doing it for such targeted problems, we should think about other performance metrics also, like false positive rates. And another challenge or problem while applying ML to the cyberspace is lack of data diversity. Uh, suppose there is a real-time data where I'm trying to understand some distributed denial of service attack is happening currently in the network, and I want to monitor it. So when I try to capture the network traffic, usually 90% of the data will be genuine traffic. Only 10% of the data will be attack traffic. So when I capture that kind of traffic and when I label it as attack and non-attack, straightforward, it is a class imbalance problem. And which is very wrong to start off building a ML algorithm which is class imbalanced in nature. Because we all know that we need to have 50-50 or equal number of classes. The data distribution among the classes should be equal. Only then the algorithm is going to learn well, it is going to generalize well, and there will not be any overfitting, underfitting, these kind of issues. So, but to get that data as is from the real traffic is it's not possible because attacks are always going to be lesser than the genuine data. So attack traffic is also always going to be less than 10% of the actual data. So this is a problem which is there in cyberspace, lack of data diversity. So we have to think about how to solve this problem whenever we are going to apply AI to the cyber problem. Uh, the third and more recent problem is adversarial attacks in the cyberspace. So, adversarial attacks are situations where an adversary or a hacker is trying to attack the ML model itself and trying to confuse the ML model to make wrong predictions. So, if an attacker, suppose we have the any spam detection algorithm itself, like even your Gmail uses spam detection algorithm, right? So in that spam detection algorithm, some attacker is going to go and confuse the ML model in misclassifying. He's able to convert the labels of spam into non-spam and non-spam into spam. If an attacker does that, then imagine the situation of all the people who are using it. So the things will become toppled altogether. So this problem is called data poisoning problem. So if the security of the ML algorithms which are being implemented is not taken care of, then adversarial machine learning attacks are something which is very real right now and they can happen. So data poisoning and use of systems like GANs, generative adversarial neural networks, and manipulating of the algorithm. So these are some problems that are very real and that can happen. Another fourth problem is privacy concern. So actually speaking, if any organization or company falls under a cyber attack and they have collected some data, they will usually have logs and other attack like some forensic data they'll have with them, so which can help us to fine tune and build better systems. But if a company has such kind of has undergone such an attack, right, they won't come out openly in the public because it will tarnish the image. So mostly 70% of the companies which have gone under a cyber attack will not reveal that they had such a situation and they will not reveal the things. So that is also a problem which is not helping all of us learn better. So very rarely will people come out and tell that my company has gone under cyber attack because they are worried that their image is getting tarnished and customer loss will be there and all. So these are some challenges and limitations when I'm trying to apply machine learning to the cyberspace. I'm going to talk about two industry case studies. This is the first one, which is the Kaspersky case study. So all of us know Kaspersky. It's the most popular, one of the most popular antivirus, which is there, right? So they have published a lot of white papers. So if you're interested in doing some work in the cyberspace with AIML, I would recommend going to the Kaspersky website and looking at their white papers. They have 10 to 15 white papers published. Of course, they are white papers, so there is not they're not as intricate as research papers, but just they would have given a base idea about what work is happening in their company. They will not reveal their trade secret or whatever, but at least we can get a base idea about what how something is going on, right? So in their white paper, there is one white paper in particular which talks about how ML is applied in their antivirus detection systems. So there they say that since they are a very old company and they have customers all over the world, if you have installed Kaspersky, if you see the working of the antivirus system, right? Whenever you are coming across some virus files, right? They are also taking backups. If you see update your database, like that one command will keep coming. So they have a database where every virus that they have come across through their customers, they are taking the signatures. So they are taking the signature and what they are doing, they are developing their own database to be much stronger. So they have a collection of lakhs of viruses signatures come across through various customers that they have, and they have built a very large representation of their data set. So this using that data set, they're trying to train a model, and their aim is to have a system which has very less false positives. That means that whenever a system like a file is a virus, they want to make sure it is declared a virus and not as a non-virus. And they are also their aim is also to have algorithms which will allow them to quickly adapt to any changes. So like how we are learning more about the positive aspects of AI and other things, the attacker also is learning along with us. They are also using LLMs to develop new kinds of antivirus, malware, and all of that, right? So the speed at which the malware hackers are growing, at the same speed, we also have to quickly adapt. So if a new algorithm comes into picture, immediately their antivirus system should be able to detect it. So that is these are the aims that they have set for themselves. And this is from their white paper, and I quote from the white paper that we must train our model on a data set that correctly represents the condition where the model will work in real time. And this makes the task of collecting a representative dataset critical for machine learning to be successful. So they are emphasizing that the data should be properly labeled and it should be very correct and distribution should be good. And in their training phase, they are making the model learn with both benign and malicious executables. These are the two classes that they are training, and they are developing their predictive model. After learning like this from known positive and negative test examples, in the protection phase, they are testing with one unknown executable, which could either be positive or negative in nature. Then they are applying their own predictive model and they're making the decision. So like any other ML model. So how they are doing it is, earlier they were using heuristic features. So heuristic are these just intuitive features that we develop. So they are using code fragments. So we can easily distinguish between malware and non-malware based on the code or the opcodes of the system. So based on the opcodes of the system or the code fragments, and hashes of the code, they are able to distinguish between benign and malicious files. Based on the file properties also, they are able to distinguish. Along with that, they are developing some combination of these features. So their main goal is to somehow combine the features and as quickly as possible, distinguish malicious and non-malicious files, because efficiency and time go hand in hand for them. And they're also making sure that server-side polymorphism. So polymorphism is where mild modification in the code will change the virus. So if you have virus A and B, you can do some polymorphism or code at the code level, opcode level, make some modifications. It will look and feel exactly like a new program, and the antivirus might miss it sometimes. So their aim is to also tackle polymorphism, but the algorithms which they had developed earlier were ineffective in detecting polymorphic malware. So then they started doing some more research and they came up with one patented word which is known as LSH, location specific hash. So all of us are from cyberspace, so we know what is a cryptographic hash, right? So cryptographic hash is like when even if you change one bit of a file, the cryptographic hash of the second file will be totally different from the first file. So that is the beauty or speciality of the cryptographic hash function. So these are so if we consider that these are all files, so if two files who have, they are actually very similar, less than one word is different in both of them. So when I generate cryptographic hash function for the first file and the second file, they will be very far apart. Because it's a cryptographic hash, even one bit change will drastically change the hash function. But they developed a specialized kind of locality sensitive hash function where if there is very mild difference or the two files are very similar, then their location specific hash will be same. Like that, they generated that algorithm. And if two files are here, if one word is different, here maybe one or two sentences are different in two files, then their cryptographic hashes are very far apart. But their location specific hashes fall in the similar area. Same way, if two non-similar files are there, then definitely cryptographic hash will be too far apart and location specific hash function also will be far apart. So why they developed this is, if there is going to be polymorphism in a malware, so one file is a malware, slight modification the attacker has made and created a new malware. So still their location specific hash function will fall in a similar area. So you can, even though you do not know what is that second file, because of it being very similar to an already known file to you, you can still put it in the bucket of malware. So that is how, using this mechanism, Kaspersky is able to detect even unknown files. So every file which is already there in their database, if they are detecting, it's not a very great thing. I mean, no, everybody can do it. We can write code and we can do it. If just you have to match what is there in the database and what you are having. But they are able to even identify unknown files from the database and correctly tell. That too, with correctly they're able to tell whether it is malware or not malware based on such techniques that they have developed. Now coming to the machine learning part, they have developed they have used both classification and clustering for doing malware detection. So they are taking any executable file, and initially in the first level, uh, they are taking only few features, because here how quickly are they able to classify, that is more important for them. If it's a malware file, very quickly they should be able to distinguish and quarantine it, right, before it starts affecting or working on the mission. So what they do is, initially, firstly, they'll have some lightweight features, lesser number of features, so that the model will quickly classify. And you just want to put it into malware or not. That categorization you want to do quickly. And then if you put, if that like suspicious or non-suspicious, that way they are going to firstly classifying. And if it is suspicious, only then they will go to second level, where they will do some more heavyweight machine learning, which will take little bit more time, but then they are able to correctly tell whether it is malware or not. So initial step is known as pre-detection step, and then they do come to the actual detection step. So if something is not looking suspicious, they won't waste their time and effort in further investigating it. Only if something is suspicious in the pre detection step, they're going to put more effort and try to classify. So this way they're able to quickly put things into malware or non-malware buckets. And they have written sort of this methodology. So for doing this, they are using classification. It's a two-stage classification that they are doing. Also, they are also using clustering for certain kind of network traffic. So how they are doing clustering is, initially this is the incoming traffic. So obviously the green ones are benign, red is the attack, and the gray ones are unknown. It's not necessary that every time whatever is incoming, you're able to put it into these two buckets. Some unknown category also it will come into. So quickly they will cluster. And all the red ones, they try to map it as attack, green ones as non-attack. And if it too much of gray is there, or there is a mix, like you're not able to correctly classify, then human intervention is required. And human being is then looking at it, and then only we are able to distinguish. So this is for incoming traffic streams. This is the Kaspersky case study. So the highlights from this is how they're able to do it so effectively is because they have the correct data. They have good amount of data, and they have made their model learn from this data. So they have access to it. They being the industry giant and being in the industry for almost 20, 30 years, they have access to so many user files records, and they have built a good database. So that itself is their USP. And they have hired some good people who are working in machine learning, and they are trying to combine ML and AI together. And they have built sufficient user base for incoming newer traffic as well. So tomorrow, suddenly, if a new malware comes, one of their machines which is deployed in some client machine will immediately pick it up, and then that signature will be passed on, and they're going to enhance their database. So they are able to do it, and they are applying multi-layered approach for detection of malware. So that's how they are able to apply and successfully prove that AI/ML can be applied in real-time things. The second case study which I want to talk about is Cisco case study. So Cisco also, it's very popular as a networking company, right? All the firewall switches and other things. So they being the forehead of this networking space, they have done some. They also have a good R&D department, and they are doing a lot of work in using AI in the cyberspace. So they have actually captured a lot of traffic, and what they have done is in 2015 itself, they have captured some malware samples and some non-malware samples. All of them are TLS encrypted traffic. So all of them are encrypted traffic. So if traffic is encrypted, how can we distinguish whether the incoming packet is malware or non-malware? So it's a very difficult task. It's a very tough problem statement. But they have taken that incoming flow traffic, and they have studied the metadata of the TLS traffic, and they're able to classify whether it is incoming traffic is malware or not, in spite of it being encrypted traffic. So how they have done it is, they have done it through supervised machine learning framework, which we have developed. So they have developed. So I think you would know what is a TLS handshake, right? So TLS handshake happens. So in the TLS handshake, In TLS now 1.3, handshake has become abbreviated handshake. It has become smaller. But in TLS 1.2, the handshake needs at least 4 round trips between the client and server. So in the initial part, client hello, server hello, and client key exchange parts, until you get this chain cipher spec finished message, everything is unencrypted. Only after the chain cipher spec message, things are in encrypted fashion, right? So when until it's in the red as per these arrows, it is unencrypted. So when this unencrypted traffic you are capturing, either using Netcat or Wireshark, and you do some analysis through the metadata, you can make out distinctions between malware and non-malware traffic. So that is what they have done. So they have collected traffic by doing some Google searches, and they have used a best of malware also for doing for this is for genuine traffic, this is for the malicious traffic, and they have collected this traffic. And from the client hello parts, they're able to fingerprint and in the client hello you have cipher suits, you have some extensions, and you have some other metadata information. So using that information, they have applied machine learning and built their own feature set. And using some sequence numbering and TLS metadata information, they have built a 197 binary vector feature. And with almost 99% accuracy, they are able to classify benign and malicious traffic. So they have taken more than about a crore flows, 2 and 4 in the Wireshark. And they have taken 2 sample sets, and they have done this and published it in the open source. So all these methods are actually telling us that people are working in real time in integrating cyber and AI subspaces. And we in our lab also have done some work where we have integrated AI into the cyberspace. And some of them are published, some of them are patented work that I have put here. So out of these 2 case studies, I will just go through with you. So we have also done encrypted traffic classification, where we are taking encrypted traffic from various applications which are encrypted in nature, and then we are extracting the metadata. So from the PCAP files, we are extracting the metadata, and we are doing some metadata analysis. So fine-grained deep packet inspection or metadata analysis we have done, and after that we are trying to do application identification, and from the metadata itself. And to augment our results, we have tried machine learning also. So this is the data set we have taken. It's an open source data set. So where you have various chat applications like Skype or Facebook, various email applications, various file transfer applications, peer-to-peer applications, streaming data, VoIP, and web traffic also. So this is an open source data set. We have taken this. A huge number of files will be there. So from this, we have extracted some PCAP files, and we have generated our own data set, and these are the results. So we are able to pinpoint Netflix, torrent email, and others. If using actually random forest is giving us very good accuracy of 99%. So what is the meaning of this is that in spite of the application traffic being encrypted, we are still able to identify the parent application which has generated the traffic. So how is this useful if you say, suppose there is incoming traffic through a firewall, and sitting at the firewall, the network administrator wants to identify whether the incoming traffic is malicious or not. At least if you are able to identify, if the traffic is encrypted, you can't go up to the payload level and tell, because if it's encrypted. So at least if you are able to identify the application, and if it is a Netflix or YouTube data, then you can be rest assured that it is a standardized application. So the chances of it being malicious traffic is less. So we can at least identify the application and then decide whether or not to further investigate that packet. So that is one work that we have done, and as at the network administrator level, it will be very useful if we are able to do network encrypted traffic identification. Next work that we have done is malware analysis in mobile applications. So this work is published as a paper. So in this work, we have taken various Android applications. So being in the University of Hyderabad campus, we had access to a lot of student phones. So one of our lab students collected applications, because what happens is most applications which you take from Google Play Store, right? They're already verified 2-3 times by the Google Play Protect. So you can't, nobody, a malicious person, can develop a malicious app and upload it into the Google Play Store. Google has very stringent rules for screening every app that is uploaded into the Google Play Store, right? So we cannot directly upload. So, but how else malware is getting introduced into mobile phones? There are some third-party sources where people are going and downloading. So mostly people like us, we are not like we are happy with the Google Play Store and what apps it's providing. But these students and other people, those who play games or those who want some software with higher precision. So how these attackers are actually creating these APK files or these tools, right? They think of some application which most people want to use. Like for example, students. If you say this is a new game which works very fast, something like that, they'll introduce it, they'll introduce some reward points or something like that. So doing some social engineering, they will target this community and they will create some apks which has internally some malicious code embedded, like a trojan or something. It will be embedded in that apk, and it's once it starts circulating in the student community to increase the levels or get more points or something, these people start circulating that files, and these are there in some third party websites. So there are many third party websites where such things are introduced, and it's people who are less aware of the cyber world, so they start downloading such software, and that's how the attacker gets a hook into any phone, right? So like that, when we did an adb pull, adb pull is the command to take an apk, install it into the phone, and just pull it down and understand it. So we have taken uh, um, APKs, not just from Google Play Store, but also from student phones. And but we verified and grouped them as benign and malicious malware APKs. Then from the APKs, so if there's anybody from the Android space, so you will understand that there is a manifest file in every APK, and in the manifest file you have permissions also, right? So permissions, all of us are like whenever you download an app, you have to give permissions. So, but really, do we think, or like really for this app, are these permissions required? Is question not most of us see. Us in the sense, not this audience, but generic audience like students or somebody. Just keep clicking next, next, next without reading what actually we are doing. So in that way, some of these apps seek over permissions more than what they require for their functionality. And once they do that, when such a thing happens, then there is a high chance of risk and it doing something malicious. Okay, so basically, Android is a very strong and secure thing. So there is severe sandboxing between various apps. So it is Android is basically based on Linux, but it is more secure than Linux because it is having heavier sandboxing mechanism. So, but still, if there is a Trojanized app, then there is a chance for those apps to seek more privileges or do something like LPE, low local privilege escalation, or remote code execution kind of attacks. And that is what is leading to things like the most famous or infamous Pegasus. Those kind of attacks are happening because of these things. So we extracted the features from the permissions and also opcodes. Like I was telling, malware identification can be done based on the opcodes of the program, because there are some in most opcodes there are some common in most malicious programs there are some common opcodes that are available. So we can extract those permissions and opcodes, and we have developed a machine learning model to help us categorize whether that app is malicious or benign. So by physically doing ADB pull, we took 450 apps from various student or volunteer phones, and then from the Google Play Store we took 639 apps, and there is a CIC data set, which is a malicious data set from which around 2000 malware we took, and also from various GitHub repositories we took some malicious APKs. So when we took all of these and we created our own data set, and we extracted some important features based on both opcodes and permissions, and we developed our own feature space, and this is the feature importance matrix. So which is inbuilt feature, right? So using that, we developed some important features, and these are the permission based features. So there are in permissions there are three categories, right? I mean, critical, normal, and in the mid level also there are some permissions. So the most critical permissions are internet permissions, reading the phone state, sending SMSs, receiving SMSs, location sharing. So these are all some very critical or high risky permissions which every app should not ask for it, especially if it's a gaming app or something like that. Why does it need my contact information? So these things are we analyzed actually. It's like what is the app category and what are the permissions it's asking? Like does it really deserve that? So based on that, we put together the features, and then we studied it. So we did not go because the data set size is little small. If you see, small in the sense it's only a few thousands, but about less than 10,000 in fact. So for that, we do not want to do an overkill by applying deep learning or LLM. It's really not required, just for the sake of doing it. So we applied normal machine learning algorithms, but they themselves were good enough to do some categorization. So you opcode based features, permission based features, and then we added both together and created permission and opcode based features. And we applied normal machine learning algorithms. Random forest itself was giving us very good accuracy compared to the other features, which is expected because whenever the data set is a combination of both numerical and string data, then random forest will perform well. So that is expected, and that is what happened here as well. So this was one work. Then there is another work which we did on polymorphic malware identification using machine learning. So this is an open source data set. So there is a data set called Microsoft Big Data Set. It has 500 GB of data of various assembly files, and it has 53 features. So many researchers use this data set for analyzing malware. So we have taken this data set. It has 9 categories of polymorphic malware. Each is different from the other very slightly in the way it is written actually. So we have taken these 9 classes, and since we are doing opcode based analysis, a little bit of NLP will come here. So in NLP, you have unigram, bigram, step analysis, right? So we have taken the opcode, and that opcode is nothing but comparable to text itself. So we have done unigram, bigram, and n-gram analysis for the various features. Opcodes are going to have codes like push, add, pull. These are the ones which are opcodes. No? So we used that, and we used ML algorithms. Some algorithms performed very poorly, like naive Bayes and decision tree. But here again, random forest was able to perform better, and we have got 94% accuracy in identifying the polymorphism in these viruses. So this is also a good work that one of our researchers has done. So up till now, I have spoken about how AI can be used in security. If there is a cybersecurity problem, how AI can help us solve that problem. The other way is also now happening, where these AI systems, which are supposed to solve cyber problems, are themselves falling victims to cyber attacks. So, like I was talking about adversarial machine learning and all. So, how do we and what are these problems that an AI system can face? Security problems, and how we can solve that? Is this the next maybe 10-15 slides? So, when I'm going to apply AI in any cyber system, the safety of that AI system is also nowadays it's becoming difficult. And in these LLMs and these other things, ethics and fairness is also being questioned. So this is another problem which is there. So there are a lot of safety concerns due to the confluence of AI and cybersecurity. There are some legal and policy issues and human factor issues and other things. So those things we will not discuss out of our boundary. But we will talk about adversarial machine learning and new age malware and threats that are getting developed because of these LLMs and these new age AI techniques. So, like I said, adversarial machine learning is actually a cyber attack. Its aim is to fool or misguide a machine learning model into making wrong predictions by either manipulating the input parameters or by manipulating the model parameters. Or some other techniques as well. So, if you're interested in doing more, reading more about this, IBM has a very good starting point where you can. IBM website talks about adversarial machine learning, and they have done in-depth analysis of the various aspects of adversarial machine learning. So, this adversarial machine learning is widely being used by attackers in image classification, spam detection, and other things. So we know these Tesla cars, right? So the Tesla cars are self-driving cars. So how they are able to actually make predictions based on the traffic signals or any traffic signs like slow down or something like that. They actually use computer vision to identify any such symbols or anything and then make decisions based on that. So the attacker is actually fooling the system. I don't have that slide in this PPT, but suppose there is a 50 kilometers per hour 50 kilometers per miles in the US. So that sign is there on the road on the left hand side. Right? As soon as the Tesla car sees it, it should make sure that 50 kilometers speed it's maintaining. So what these attackers are doing is to the original image, they are embedding some noise. This noise is not distinguishable. It's like if this image has been embedded with this noise, it will look like this, which is to a normal human eye, there is no difference between the first and the third one. But actually, some noise is getting embedded, and the machine will. So what is 50 kilometers per mile sign? It will see as a stop sign. And instead of speeding ahead, it will stop there and which will cause the other vehicles to come and bang in from the back and there will be accidents. So this has happened. It has been proven that these computer vision things in the Tesla cars are prone to such kind of attacks. So this in this figure, this this picture is of a panda, but slightly some blurriness is there. So the machine is predicting with 57% accuracy that this is a panda. To this image, I am embedding an epsilon noise, which is in this like this, and when you embed this picture with this, it will look like this. So to a naked human eye, it looks the same. But the same algorithm which predicted this image as 57% as panda is predicting 99% as gibbon, which is some other animal. So the accuracy has increased, but that too for a wrong class. So this is a problem in adversarial machine learning. So these AI attacks are actually targeting the integrity, the availability, the replicability, and the confidentiality of the various uh, cyber systems. So these are possible in image, like I said, in image classification or semantic image segmentation. They are being done in uh, machine translation and other such attacks, and they're also being done in malware detection and intrusion. So they're able to poison the model and make them do misclassification. So if the AI model is not secured properly, then it is prone to such kind of attacks. So how do we safeguard now? Now that we are telling, first we told AI can help us solve many cyber problems, but then we told that AI itself can be prone to attacks. Then how do we solve this problem? Is we should ensure that whatever AI you are using to safeguard your cyber infrastructure should also be safeguarded. So for doing that, we have to do regular security audits. We have to secure data handle. We have to perform secure data handling. We have to ensure that the algorithm is robust. That is, if anybody is trying to manipulate or play with it, they should not be able to do. So we should uh, cover it properly. User verification should be done. Like who is accessing that model? Who are the people who have access to it? So proper authentication mechanisms should be in place. Systems should be always updated and patched. So if all this is done, we can ensure the integrity of the AI system. So in the future, in this AI and cyber space, if you're interested in doing some research, quantum computing threats are being proposed. The government is also funding a lot of quantum work. If you have seen the DST website and all, so a lot of quantum missions, national quantum mission and all that is being proposed, and government is investing a lot of money in that. So we can write some proposals there. Explainable AI is one another important field in which currently we are also doing some R&D. And AI in autonomous response is some another new field, emerging field. Role of AI ethics in cyberspace is another field which is emerging. So these are some futures threats, trends we envisage. So the best practices while using AI ML in cyberspace is always prepare your and data, clean your data properly when you're using it. Do proper model testing and training, and after doing it, usually whenever we develop a model and deploy it, we think, okay, that's it now. But it is not the case. We should continuously monitor the model. Every 2-3 months, we should understand whether it is working properly, the results are as per how we designed it or not. And what is lacking is collaborative defense. Like I said, people, if they come under cyber attack, are not openly revealing it because they feel that it will tarnish their image. But if companies come up and start revealing the info, then information sharing will really help globally to enhance cyberspace security. So regular updates and trainings are required for ensuring we avoid these issues. So currently we are working on Gen AI explainable. So we have actually deployed some LLMs, large language models and other things, and we are working in them. So nowadays you don't even require high-end machines to work in this space because Google will give you even Colab is giving you a lot of things, even through GitHub and other such repositories or cloud repositories, we can do a lot of work in LLM space. Earlier, people were bound by their infrastructure, the size of their infrastructure, but now, thanks to each company competing with the other and trying to prove the other better, they're giving us a lot of open things. But we also should be careful about what we share and what we use those open things for. There is a concept of explainable AI. There's a concept called uncertainty in AI, and also still in certain domains, even in this era of internet and all, we have some data sets which are very small in nature. So handling that smaller data sets is also a challenging problem, which also we are working on. And there is this problem of uneven class distribution in many domains, not just in cyber, in medical and many domains. So we are working on uneven class distribution problem as well. And we have a high performance computing machine in our organization. So we are using that to see how we can use work on big data sets using HPC and argument AI in that. So these are some works our lab is doing. Uh, in conclusion, we can say that AI and so going further, there is going to be a crisscross or intersection of cybersecurity and AI. So the cybersecurity landscape is going to be affected by the evolution of AI and vice versa. We can't avoid this. And so one thing we should make up our mind that both these technologies are here to stay. So it's better that we start learning them and understand that they're going to live together. But whenever we are using them, we should be fully aware and cautious of what we are doing. Because when we are introducing AI in the cyberspace, along with the existing issues and attacks in the cyberspace, we are introducing a new attack surface in AI through AI in the cyberspace. Because that attack surface of AI also needs safeguarding and security. So that we should be aware of, and then we are ready actually to go ahead and embrace AI in the cyberspace. So this is from my side. Any questions I'm ready to take.
Ma'am, like that image of panda, you have said that, and many times we have heard this that the added noise in that particular image restricts the machine learning model to classify it correctly.
Yes.
Uh, my sensor said that whatever we see with the naked eyes is the pixel, right? So if the pixel is not getting altered because of that noise, and that's why we are not getting it from our naked eyes.
Yes.
Then why machine learning model? Because it is also taking data from the pixels only.
The At the pixel level there is a modification. At the pixel level there is a modification which a human eye is not able to detect.
Why, man? Why is it so? Like because it should be then it should be distracted or it should be.
There are mild noise introduced into every pixel in the complete image. So it is not possible for a human eye to detect it. So it is this adversarial attack is more proven in image data than in tabular or normal data. Because in a normal data, if some numbers become ultra, we are easily able to identify.
Right.
But in an image, since it happens at a minute pixel level, it's very difficult to identify with naked eye. That is why these adversarial machine learning attacks were first happening only in the image space. Now they are happening even in other spaces. Like we are investigating one such thing where it is happening in other data sets also, not just image ones. But in non-image, it's very easy to understand, like you're telling, because numbers will be, something will be more. But if it happens, suppose you have 1 million instances, and a few instances alone somebody has done, then a human inspection will not reveal it because we might miss out some things. So, but in an image, it is more.
The entire pixel is not being
Yes,
altered.
yes.
The part of the pixel has been altered.
Certain parts of the pixel are getting, that whole epsilon noise is getting distributed in the whole image. So how will we identify? It is not possible. And the attacker is smart enough to ensure that the human being is not able to identify. So they are making sure that you can't identify with naked eye. In fact, you don't even have to embed it. Suppose, okay, I don't have it in the PPT, but there is one I had one slide, like where on that stop sign, right? Some miscreant will stick a sticker, small sticker. That sticker itself is able to confuse the ML algorithm. Yes. If a human being sees it, he would have stopped because he can see. But that small sticker itself is enough for it to confuse the models. So, like we have seen in movies, like where CCTV footage is analyzed, and if somebody who's trying to rob a bank is wearing a cap or a glasses with something they'll wear, right? Some IR radiation, something. Then the computer is not able to. But if it was a human being, he can see, right? But the computer is only using computer vision software, so they are not, that face will become blur at that point, and so the same thing here also. So if it's a human being, would have seen that, like they can identify that person, even he is wearing the glasses or the cap. But if it is going to be through computer vision, it will not be able. The blurriness will be there. Same thing here.
But it can be identified through discriminator using GAN.
Yes, which one, ma'am? GANs. Huh?
LLM model GANs.
GANs are employed as helping us to detect these things. So not everybody is using it. GANs can be a protection mechanism, like you're telling. Autoencoders or GANs help us as denoising filters, because mostly we use them for denoising purposes. So if once we build a model and we are putting data into it, it is better to screen it, like you're telling, through some denoising filters. GAN is one example of such denoising filter, which will help us identify. There are many research papers now where GANs or such autoencoders are used for denoising purpose for preventing adversarial machine learning attacks. Anything else? You can inform sir that I'm done. With that, we come to the end of today's faculty development program session. So I sincerely thank our speaker, Dr. Pradeepthi ma'am, resource person, for sharing such insightful knowledge about AI in cybersecurity. And ma'am has discussed about some case studies like Kaspersky and Cisco. So they're very helpful, ma'am. Thank you. And I have also I would like to thank all the participants for their active involvement for today's session. We hope the session was enriching and valuable for all the professional for your growth. So looking forward to your participation in future sessions. So thank you all once again. Have a great day.
Thank you.